This video is part of a series of videos on coordinate geometry and conic sections. We're going to go through a problem together here. It says write the equation of the line tangent to the circle at the point 2, 5. So before we get into it, let's just kind of see if we understand what this problem is talking about. So on the Cartesian coordinate plane, this particular circle is centered at the origin, and we recognize that because these values that are squared, we don't have, for example, x minus 3 quantity squared. That would be a circle that was centered, it would be shifted over 3 units to the right. There's nothing like that happening here, so this circle is centered at our origin. And the radius of this circle is equal to the square root of 29, which is somewhere around a value of about 5.4. So if I was to imagine this circle, 1, 2, 3, 4, 5, around 5.4, there would be this circle centered here, and it would go 5.4 units in all directions. So we might imagine a circle something like this. It's probably a little bit smaller radius. So we're not asked to find that circle. That circle's just part of the problem. We're asked to find the equation of a line that's a tangent to this circle, and it's a tangent to this circle at the coordinates over 2, up 5. Well, it has to be the case that that point is going to be actually on this circle, and a line that's a tangent to this circle would be going through just at this one point right here. There's a couple ideas that we need to kind of discuss here. If we have a tangent, if we have a radius, we draw a radius to a point of tangency, it's always going to be perpendicular to the tangent line. So that property is something that we'll definitely be using and exploring. Right? The radius drawn to the point of tangency is going to be a perpendicular line. And also, perpendicular lines have slopes that are opposite reciprocals. Another way to say that is the product of their slopes always equals -1. So for example, if I had a slope of 2/5, the slope of a line that would be perpendicular to that would be -5/2. And you can see when I multiply these, I get a product of -10/10 or -1. So that'll always happen. And knowing this allows you to build, right, the slope of a line that's perpendicular when you know the slope of another line. Armed with this fact, I have kind of an entry point to this problem, because I can certainly calculate the slope of this line, right? This radius drawn, or segment, radius drawn from obviously a radius is drawn from the center of the circle to this point of tangency. This particular line has a slope that's equal to, because this point is located at 2, 5, and my origin right here is 0, 0. I know that the rise is 5 and the run is 2, right? So this radius, right, has slope that is equal to 5/2. That means that the slope of my tangent line, which is perpendicular to that radius, right, this must have a slope. Sorry, I'm off screen there. This must have a slope that's equal to -2/5. So what we have here is we have a known point. We have a point at 2, 5, and we have a slope of -2/5. And if we are asked to find the equation of a circle, this circle right here, x squared plus y squared equals 29 at the point 2, 5, I think we're pretty much on our way to being done, right? This is the general form of a linear, or the slope-intercept form of a linear equation. Y equals the slope times x plus the b, the y-intercept value. And if I look at this, I know the value of the slope, right? I know 2/5, or negative 2/5 rather. I also know, right, for this line over here, this tangent line, I also know that it contains the point x is 2, y is 5. So if I plug those values in, right, x is 2, and multiply by 2, and y is 5, I have at this point an equation where I know an x, I know a y, and I know a slope. The only value that I don't know is b, my y-intercept. So if I solve this for b, right, I've got 5 equals negative 4/5 plus b. And if I add 4/5 to both sides, I'm looking at b plus 4/5 is equal to, 5 plus 4/5 equals b. And of course 5 we could rewrite as 25/5. So 25/5 plus 4/5 is b. Therefore b must be equal to 29/5. Okay, so I at this point know the slope of this line, and I know its y-intercept. So at this point I know the equation of that line, right? This equation, the equation of this line right here, the line that is tangent to this circle at point 2, 5, it has the following equation: y equals negative 2/5 x plus 29/5. And 29/5 is around 5.8. It's bigger than 6. So if I look at this, it's certainly reasonable that my y-intercept would be somewhere, around a value that's more than 5, certainly. So at least this is probable that this is correct. For further verification, I went ahead and plotted both the circle and the line. And when I bring that circle on and I bring the line on, it certainly appears that these two objects are meeting at the point x is 2, y is 5. And I can also, I think, demonstrate that by asking GeoGebra to intersect these two objects. So if I want the intersection of this line and this circle, it's at point A, and that point is at 2, 5. So we have indeed found the equation of the line that is tangent to this circle, the circle x squared plus y squared equals 29 at the point 2, 5.